The purpose of today's lab is to measure distances that are far too small to be measured by an ordinary ruler like a meter ruler. The accuracy of any measurement is limited by the markings of the equipment, of the measuring instrument. That means there is a limitation to the accuracy you can get from any measuring instrument. Now, what is the smallest distance that can be accurately measured using a meter ruler? The smallest division on a meter ruler is a millimeter, and that is the accuracy of this instrument, and that is called the least count. So what is the least count of the meter ruler? It is 1 millimeter, the smallest division marked on it. Okay, I'm going to show you few more measuring instruments. I want you to write down the least count of that instrument. What is the accuracy of that instrument? What is the least measurement that can be made accurately using that measuring instrument? Here I have a beaker. Look at the markings on it. If you look here, you got 400. Now, what is the next marking? 450, 500, 550, 600. So what is the accuracy of this? The smallest amount you can measure accurately on this is a 50 milliliter, and so the least count of this is 50 milliliter. And now I'm going to show you a couple more and write it in your report. What is the least count of this instrument? Well, this is again a beaker. Alright, let me place it where you can read it. Alright, what is the least count of this beaker? I want you to write down that in your report. That's the first one. Alright, I'm going to show you another one. What is the accuracy of this? In other words, what is the least count of this measuring cylinder? What is one division on this equal to? And that is the least count. Alright, look at it carefully and write down the least count of this. Okay, here's another one. Write down the least count of this. I'm sure you can read that, can't you? Well, I can read some of this for you. That's a 3, 4, 5, 6, 7. And you can see between 3 and 4, there are 10 divisions. So write down the least count of that measuring cylinder. I have now another instrument. I want you to measure the least count of this. This is a meter that measures current in milliampere. Alright, measure the least count and enter it in your report. Okay, how do we measure distances that are less than a millimeter accurately? For example, I want to measure the length of this rod that I have kept on a ruler. Now, this ruler is marked in centimeter and millimeter. This is 0, this is 1 centimeter, 2 centimeter, 3 centimeter, and so on. I want to measure the length of this rod. You can see this ruler will allow me to read only up to here, and that is 1.1 centimeter. It will not allow me to read this remaining small length. In order to measure such a small length, we use a scale known as a vernier scale. A vernier scale. Now, to construct a vernier scale, what we will do is, this scale is going to be called the main scale. So let me write down, this is my main scale. Alright. Now what is one division on this main scale? Is 1 millimeter. I'm going to take 9 divisions of that and divide that into 10 parts. Alright, now when you do that, you construct a vernier scale. Here I have constructed a vernier scale. What have I done? I have taken 9 divisions from the main scale and divided those 9 divisions into 10 equal parts. Now can you tell me, if one main scale division is 1 millimeter, what is one vernier scale division equal to? Well, one vernier scale division is, I'm going to write it like this, one vernier scale division equal to 9/10 of a main scale division, which is 9/10 of a millimeter. Therefore, what is one main scale division minus one vernier scale division? What is the difference between one main scale division and one vernier scale division? What is the difference between one main scale division and one vernier scale division? It will be 1 minus 9/10 of a millimeter, and that is 0.1 of a millimeter. You see, you can now say the difference between one main scale division and one vernier scale division is 0.1 of a millimeter. That's 0.01 of a centimeter. Now what is the significance of this? I want you to look at this and answer this question for me. Now if you look at the first vernier scale division and the first main scale division, they are not in the same line, are they? No. Tell me, if I push the vernier to the right so that the first vernier division is exactly in line with the first main scale division, what is the distance moved by the vernier to the right? It will be the difference between the main scale division and vernier scale division, that is the least count. Now if I push the vernier to the right so that the second vernier division is in line with the main scale, you see that? The distance moved by the vernier to the right will be 2 times the least count. Alright, I'm now going to show you the model of a vernier, and I can ask you more questions based on that. Here I have the model of a vernier scale. If you look here, this is the main scale. Let's say this is in centimeters, 0, 1, 2, and so on. That means each division on the main scale is a millimeter. And if you watch carefully, we have taken 9 divisions on the main scale and divide that into 10 equal parts. So there are 10 divisions on the vernier, that is the vernier 0. When the vernier 0 is in line with the main scale 0, the gap, you see, I can move this vernier along the main scale. When that gap is closed, the 0 of the vernier is in line with the 0 of the main scale. Alright, now if you now look, the first division of the vernier is not in line with the main scale division. Suppose I move it so that now it looks almost the first division of the vernier, is that right? The first division of the vernier is now in line with the main scale. Now, what is the distance of that gap now? The distance of that gap is the difference between one main scale division and one vernier scale division. That is the least count. That is 0.01 centimeter. If I move it further to the right so that the second vernier division is now in line with the main scale. Now, well, yes. Now the second vernier division is in line with the main scale. The distance moved by the vernier, this gap, is 2 times the least count. Now, if I want to measure the length of this marker, what I want to do is I keep it and create that gap. That means the length of the gap is the length of the marker. Now, how do I measure it? I first of all come in and look at the position of my vernier 0. My vernier 0 is to the right of, what is this reading? Can you look at that reading? This is 1 centimeter, 1.1, 1.2. I can read up to 1.2, but I cannot read that very small distance after that. To read that small distance, you got to ask, how much has the vernier 0 been pushed from this 1.2? Now, to answer that, you got to look at the vernier, each of the vernier division. Is the first vernier division exactly in line with the main scale? No. How about the second one? Yes, the second one is in line. That means the vernier 0 has now been pushed to the right from here, a distance equal to 2 times the least count. If you understood this concept, now tell me, what is the length of this object? I have used this object so that it pushed the vernier to the right. Alright? Now I can measure up to 1.1 millimeter, and I'm going to call that the main scale reading. The main scale reading. What is my main scale reading? It is 1.1 centimeter. I need to now find how much, what is this distance? How much has the vernier 0 been pushed from this reading, from 1.1? In order to answer that, I now look at each vernier division and see which of the vernier divisions is exactly in line with a main scale division. Number 1 is not, 2 is not, 3 is not, 4, 5, look at 6. Number 6 is exactly in line with a main scale division. And I'm going to call that the vernier scale reading. I'm going to write it like this. Vernier scale reading is 6. It means the 6th division of the vernier scale is exactly in line with a main scale division. That means this distance that has been pushed to the right is 6 times the least count. And I'm going to call it the fractional length. The fractional length is therefore 6 times the least count. The least count is 0.01 centimeter. That is 0.06 centimeter. So this distance is 0.06 centimeter. Therefore, what is the length of the object? It is 1.1 plus 0.06. So to obtain the correct length, we say main scale reading plus vernier scale reading multiplied by the least count. Look at that again. Main scale reading plus vernier scale reading multiplied by the least count. Now, if I write it over here, I have a small space, or I'm going to write it here. My main scale reading is 1.1 centimeter. And vernier scale reading multiplied by the least count is 0.06 centimeter. Therefore, the result here will be 1.16 centimeter. You cannot see it there. So I'm going to write it over here. The correct reading is 1.16 centimeter. That is the correct length of the object. Okay. Well, here I have a real vernier. This is called a vernier caliper. And you can see our main scale is the scale below here. Do not look at the scale above, that is inches. So the main scale is the one below. Look at that, 1 centimeter, 2 is hidden here, 3, 4, 5, and 1 division on the main scale is 1 millimeter. And if you look, 9 divisions on the main scale are divided into 9 equal parts, right? Okay, I can move the vernier like this, creating the gap. When the gap is closed, the 0 of the vernier and the 0 of the main scale are in line. There you are. Okay, if you understood how to use the vernier, try and measure this length. I want to measure the diameter of this marker. All right, try and read this. What is this reading? I'm going to tweak it a bit to give you a maneuvering ability to read. All right, what is, give me a second. Now, what is this reading? Can you tell me what that reading is? Look at that and tell me what is the diameter of this marker. All right, what is the main scale reading? The main scale reading is, if you look there, that is 1.8. Is that right? 1.8. And what is the vernier scale reading? Which division of the vernier is exactly in line with the main scale? Can you look at that and tell me what it is? I think it is this, which is the 7th. So the vernier scale division is 7. So what is the actual reading? It will be 1.8 plus 7 times 0.01. That means that will be 1.87 centimeter is the diameter there. Now, I am not going to instruct you again how to read the vernier in the lab. I will simply keep the object here whose length is to be measured, and I will ask you to take that reading. All right? So you must be able to read that. I hope that is clear. First of all, obtain the main scale reading. That is the reading just to the left of the vernier 0. That's the one. All right, that's 1.8 centimeter. My hand's not steady there. And then look at the vernier division. Which of the vernier divisions is in line with the main scale? Multiply that with the least count and add it to the main scale reading. All right? Okay. Another instrument that can measure length more accurately is a micrometer screw gauge. I have part of the micrometer screw gauge visible on the screen. Actually, most of it. Now, if you look at it, there are 2 important parts for this. There is an outside round scale which is connected to a screw. When I turn it, if you notice that the gap between here is increasing. So when I turn it backward, the round scale is moving back, creating a gap here. That means this gap is a measure of the distance the round scale moved backward. Now, when you work it forward, I'm turning the screw, and once it is completely in, Listen to the sound. Now the screw is completely in, this gap is closed, and there are two scales I want you to notice. One is the round scale, that is the 0 of the round scale, and how many divisions are there on it? 5, 10, and if you come here, that will be 45, 50 divisions. There are 50 divisions on the round scale. And look at the linear scale, scale marked on the cylinder that is not moving. I'm going to work it back and look at the linear scale. This is 0, then 0.5, 1, 1.5, 2, 2.5. You see, that is how you must read the scale. That means the division on the linear scale, one division on the linear scale is actually 0.5. So this will be, there you got 0, 0.5, 1, 1.5, 2, 2.5, and so on. All right, now I'm going to work the screw forward until I hear the tick sound. Okay. Let me see if this light, okay. I'm going to see which is more advantageous for you to read. I don't want to make too glare over there. All right. Now the screw is completely in. When the screw is completely in, the 0 of the round scale and the line of the linear scale are in the same line. You can see that. All right, I'm going to rotate the screw 10 times backward. Watch this. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now tell me, what is the distance moved by the round scale on the linear scale? Can you tell me what that distance is? Well, you can now tell me. It is 5 millimeter. So when the round scale is rotated completely 10 times, it moved a distance of 5 millimeter. Now tell me, if it is rotated completely once, what will be the distance it will move? For 10 rotation, it moved 5 millimeter. Therefore, for one rotation, it will move just 0.5, from 0 to 0.5. Now, one rotation means the round scale goes through 50 divisions. Is that right? 0 to 50. So, when the round scale is rotated through 50 divisions, it moves a distance of 0.5 millimeter. Therefore, if it is rotated through, just watch this, rotated through just one division, what is the distance it will move along the linear scale? It will be 1/50th of 0.5, which is 0.01. Is that right? 1/50th of 0.5. And that is 0.01 of a millimeter. That is 0.001 of a centimeter. And that is the least count of this. So make a note of that. The least count of this is 0.001 centimeter. Or in millimeter, it will be 0.01 millimeter. We're going to use the measurements in millimeter, so keep the least count in millimeter, 0.01 millimeter. How do we use this instrument? I want to measure the thickness of this object. So what I do is, I first work the screw back to create enough space. And once I have enough space, I can insert this in between and work the screw until you hear that sound. And now you must look for the reading on the linear scale. What is the reading on the linear scale? You have, there's 0, 1, 2, 3, 4. Is that right? I think you can take up to 4. 1, 2, 3. Is that, can you take up to 4? Can you see 4 there? No, you cannot. So this will be now, watch me again. 1, 2, 3, 3.5. I can read up to 3.5. So my linear scale reading is 3.5. Now, what is remaining is going to be read on the round scale. What is the round scale reading? The round scale reading is 27. Is that right? That means from 3.5, the round scale has moved back 27 times the least count. What is 27 times 0.01? That will be 0.27 millimeter. So the actual reading now is 3.5 plus 0.27. That will be 3.77 millimeter. I hope you understood how the measurement is made. Now take the complete reading you can get on the linear scale, and here it is 3.5. Then see which division on the round scale is in line with the linear scale line, and that is 27. That means from 3.5 the round scale has moved back a distance of 27 times the least count, 27 times 0.01. So this 3.5 is then added to 27 times 0.01. Okay? And now, you are ready now to take the reading on the vernier caliper and the micrometer screw gauge. Okay? Let's now measure the diameter of this piece of wire. Well, work the screw back and insert the wire in the gap and work the screw forward until you have that click sound. Alright, now what is our linear scale reading? If you look at this, that is 0. Well, that is 1 millimeter. That is 0.51. So your linear scale is 1 millimeter and your round scale reading is 31. So what is the diameter of this wire? It will be, the complete reading on the linear scale is 1 millimeter. And what is left over will be 31 times the least count. And what is the least count? 0.01 millimeter. Multiply that with 31. That will be 31 times 0.01. That is 0.31 millimeter. So 1 millimeter plus 0.31 millimeter. Therefore, the diameter of this wire is 1.31 millimeter. Is that right? The diameter of this wire is 1.31 millimeter on the micrometer screw gauge. Well, I'm now going to ask you to take the measurements. I will keep the object like this and I will ask you to read the measurements on your own. All right? Okay. In the first part of the experiment, I have 7 of these aluminum sheets. I want you to measure the thickness, the length and width. But these are squares, so the length and width are the same. And all these have the same length and width. So we will only measure the length and width of just one. You can copy and paste for all the others. The length and width of all of them are the same, but the thickness are all different. Alright, so let's measure the thickness of each of those. Look at the first table. You got to have sheet 1, and you need to take 2 readings for the linear scale and then 2 readings for the circular scale, average it, multiply the circular scale with the least count, and then add that to the average value of the linear scale. That's what you need to do. Alright, let's get going. I have labeled the sheet, so let's start with sheet number 1, measure the thickness. Alright, insert in there, and I will not now say anything. I will give you 15 seconds or 20 seconds, let's say. Take the reading now. Reading number 1. Take the linear scale reading. Now, let me give you a clue here. You see, looking at the round scale, it's so small, that means the linear scale reading is 0.5. You see? So, linear scale reading is 0.5, the round scale reading is 13. Alright, I just give you one. Alright, I'm going to change it to different position. We got one reading. I'm going to change it to another position, and you take the reading now. Alright, that's the second reading. Take the linear scale reading and the round scale reading. Done? Alright, I'm going to now go to sheet number 2. Okay. Sheet number 2, there it is. Sheet number 2. Okay. Take the linear scale reading and the round scale reading and put it in the table right away. Okay, it doesn't take a long time. Alright, I'm going to change it to another position, get a second reading. Alright, get your second reading. That's your sheet 2. I hope you've done that now. Okay? Alright. If you want more time, just pause the video. Alright, let's go to sheet 3. Well, that's sheet 3. Take the reading there. That's very easy. Take the linear scale reading and the round scale reading. Alright, I'm going to change it to another position. Alright, you want me to give that reading? Are you in trouble? Alright, the linear, okay. Let's go to number 4. Sheet number 4. Alright, take the linear scale reading and the round scale reading. That's not difficult at all. Okay, I'm going to change it to another position. Alright, take the linear scale reading and the round scale reading. Done? Okay, let's go to sheet number 5. Okay. Take the linear scale reading and the round scale reading. That's very simple. Alright, take your time by pausing the video and get exact readings. All right, take the second reading. Okay. I'm going to go to the sixth sheet. Sheet number 6. Okay, take the round scale reading and the linear scale reading and the round scale reading. Now remember, this is a very accurate experiment. I don't want you to make any error in this experiment. Okay, let's go to another reading of the same sheet. The second reading of the same sheet. All right. Okay. Can you tell me what is the linear scale reading here? What did you take? It is 3 millimeter. Yes. Okay. Let's go to the next one. I haven't arranged them in order. They are actually at random. All right. Take the first reading. All right. Linear scale reading and the round scale reading. Done. Okay. Give you another measure. Let's take the second measure. All right. We have now done the measurements of the thickness, and now we want to measure the length and width of these sheets. Well, to measure the length and width, we are going to use the vernier caliper. Let's now measure the length. I have got the aluminum in between the jaws of the caliper. You can see here. Can you see that? All right. Take this reading. In other words, take the main scale reading. All right. Does it come up to 7? No. So take the main scale reading and take the vernier scale division that is exactly in line and obtain the actual reading. So you need the main scale reading, then the vernier scale reading, multiply that with the least count and add it to the main scale reading. All right. Now keep a watch on your unit. Previously all the thickness were measured in millimeter. Convert that to meter. This is now measured in centimeter. Is that right? All right. Okay, I'm going to show you what this reading actually is. I think it is the 8th division that is exactly in line. So the reading is 6.98 centimeter. Did you get that? Okay. Now get another reading. Second reading of the length. All right, take that reading. All right, you get 2 readings for the length, and let's take 2 readings for the width. Well, they will all be the same because it is a square. All right, take the first reading for the width. And take the second reading for the width. That's the second reading for the width. You can see that's considerably different. At different points, that's the second reading of the width. All right. You can now use these length and width to all the other 6 pieces. So you have the length, width, and the thickness. How would you calculate the volume of each piece? Calculate the volume of each piece as area multiplied by thickness. In other words, length times width times thickness will give you the volume. So calculate the volume of each of these P's. Okay. Now if you look at the tables, you've got to measure the volume of each sheet, that is length times width times the thickness, and it must be in meter cube, and measure the mass of each sheet in kilogram. So let's measure the mass. I'm going to place each one on a balance, and you will measure the mass. All right. First of all, before measuring the mass, I want you to write down at the top. Look at the balance when I show you, and write down the least count of the balance. All right. Right at the top, what is the least count of the balance? Okay, first of all, we make sure that the balance reads 0. So we zero in. Okay, now tell me, what is the least count of this balance? This reads 0.01. Well, I need to zero in. So what's the least count? What is the minimum mass you can measure accurately with this? Write down at the top. And now write down the mass of sheet 1 in kilogram. All right. Okay, that is sheet 1. Write down the mass of sheet 2 in kilogram. That is sheet 2. Write down the mass of sheet 3 in kilogram. Okay. Write down the mass of sheet 4 in kilogram. And now sheet 5. Okay, sheet 6. And finally, sheet 7. In the next part, I have 6 pieces of copper. This is a copper cylinder, another copper cylinder, a third copper cylinder, so 3 copper cylinders, a copper wire, it's a cylinder also, a copper sphere, and a copper sphere. Can you actually see it? There are 6 objects. Now, I'm not going to give you the formula for volume of a cylinder and volume of a sphere. You need to find out. Now, to measure the volume of a cylinder, you need only the radius. So we will measure the radius of both these cylinders, and to measure the volume of a cylinder, I think I call this a cylinder, we need only the radius for measuring the volume of a sphere. But to measure the volume of a cylinder, we need its length or height. Let's call it length. And the radius. Alright, you need to find the formula to calculate the volume. Alright, first of all, let's measure the length of these cylinders, and I'm going to use, there are 4 cylinders, I'm going to use the vernier caliper to measure the length, and you are going to measure it. Alright? Let's now measure the length of cylinder number 1. So make a note, this is cylinder number 1, and when you measure the mass, don't confuse. Cylinder number 1, let's measure the length. Alright? Take your measurement. Have you done so? I'm going to keep it at a separate position and try again a second measurement. A second measurement for the length. Okay, so that's cylinder number 1. Cylinder number 2 is this thick cylinder. Okay, let's measure the length of that. There you go. Take your measurement of cylinder number 2. take a second measurement. Let me keep it, give me a second. Take the second reading for the length of that cylinder. Okay. The third cylinder is the small one. All right. Measure the length of the third cylinder. That is measurement 1. And take the next measurement, second measurement. So you have 2 measurements of 3 cylinders, and I have one more cylinder, that is the wire. You see that? This wire is a cylinder. Let's measure the length of that. Well, I need to move it all the way so that, okay, that means, I think you can read it, is that right? Yes, there you are. All right, take that reading, the length of the wire. All right, I'm going to give you a second reading there. There you are. All right, now we have the length of 4 cylinders. We are now going to measure the radius of these and also the radius of the 2 spheres. And what is it that we're going to use to do that? We use the micrometer screw gauge. All right, let's measure the radius of cylinder number 1. Don't confuse the cylinders. You got to keep the numbers. Let's measure the radius of cylinder number 1, and this is cylinder number 1. Let's keep it in this gap. All right, and work it forward. Okay, take that reading. All right. Okay, I'm going to keep it at a different position now. All right, take that reading. I think we need to take 2 or 3 readings. Okay, and now let's take a third reading for the radius. Okay. Well, we found the radius of the first cylinder. Let's now find the radius of the second cylinder, the fat cylinder. Okay. There you go. All right, take that reading. Can you read it well? There you are. Take that reading. And let's do a second reading on that cylinder. There you go. Take that reading. 2 readings for the radius of that cylinder. Okay, let's find the radius of the third cylinder. There we go. Okay. Take your time, pause the video, take your time and read it well. All right, let's take the second reading for that cylinder. Okay. You ready? Alright, and now let's find the radius of the wire. You need at least 4 readings for this. You know why? Because it is not quite straight. So let's take the first reading for the wire. There we go. Take that reading. Well, isn't that simple? You can read it right from there. It's, well, I won't tell you. Alright, let's take a second reading. You can see it's different because the wire is slightly crooked. So we need to take 4 or 5 readings and take the average. A third reading, look at that. Each one is different. So you got to take the average of all these. Take a 4th reading. There you are. They're all different. So take a 5th reading. Okay. Now take the average of all these. These are diameters. We were reading the diameters, not the radius. You need to divide it by 2 to find the radius. Okay. And now finally, I have this ball. We need to find the radius of that. Okay, I need time to work the screw back to create the space, because we need a lot of space for this sphere to sit. Alright, let's see if it's even possible to measure this on this. Yeah. Okay. Okay. There we go. Take that reading. All right. Have you done that? It's not difficult. Okay, I'm going to change it to another position. Take that reading. One more. All right, find the average diameter and then find the radius. Okay, now you can calculate the volume. I'm going to leave it for you. Let's now measure the masses of these objects. Okay, let's now measure the mass of each of these pieces. Start with the balance, zeroing. Alright, I'm going to measure the mass of the first cylinder. I'm not going to measure, you are going to measure. Remember, mass must be entered in kilogram. That is the first cylinder. Measure the mass. The second cylinder. Don't confuse the numbers, keep the numbers. The second cylinder, measure the mass. The third cylinder. And the copper wire. There you are. Write that in kilograms. And finally, there you are. Well, you see, I forgot about it. Look at this. I have this copper piece. Alright, let's measure the mass of that, then go back and measure its radius. It'll be interesting. Alright, measure the mass. This is the 6th piece of copper. That's a sphere. Measure its mass and write it in kilogram. Let's go and measure its radius, the 6th piece of copper. I have now got the copper sphere in between this, in the space there, and now take the reading, its diameter. Alright, one reading is enough. You take that diameter and find the radius and then calculate the volume. and we have measured the mass already. Well, what you now need to do is complete the table of mass against volume. Is that right? I have asked you to measure the mass of each of those and complete this mass volume chart. So complete this chart for each copper piece, volume in meter cube, mass in kilogram, and then draw a graph of mass on the y-axis and volume on the x-axis. Is that right? And measure the slope, and that will be the density. So how many graphs will you have for this experiment? You will have two graphs, one for aluminum and one for copper. Alright, now you know how to use a vernier caliper and a screw gauge, at least in in two experiments this semester. I will show you a reading, and I will ask you to read it, because in some experiments you need to measure distances and the diameters that are very small. We will be using this. I will not read it for you. I will just keep it in front of the camera and ask you to read it. So you must know how to read it. Okay. Answer all the questions and complete your report and put that in the assignment drop box, and you will be fine.